In this video, we'll take a look at how to use the U9233E digital multimeter. We'll go over how to measure voltage, current, resistance, and capacitance, how to test the orientation of a diode, and how to check for continuity. Voltage is one of the most crucial electrical characteristics that you'll certainly come across when testing or debugging a circuit, and the DMM will allow you to very quickly measure DC or AC voltage. To measure voltage, first double check that the probes are correctly connected to the COM jack and the voltage jack, not the 10 amp jack. The only time you'll use the 10 amp jack is when you measure current in the range of 10 amps. We'll apply 5 volts across these resistors and measure the voltage. Turn the knob to the voltage option. The default with this DMM is to measure AC voltage, so press the function button to measure DC voltage. You want the DMM in parallel with the component you're measuring when you're measuring voltage, so simply touch the two legs of the resistor with the probes. If you get the polarity wrong, the DMM will simply display a negative sign in front of the measurements. Try the same thing with the voltage divider. The voltage over the first resistor is a bit below 0.9 volts. And the voltage over the second resistor is about 4 volts. These two voltages should add up to the voltage between VCC and ground, and indeed, that's what we measure with the DMM. Measuring current with the DMM is slightly different from measuring voltage, as you need to connect the DMM in series with the circuit. We want the current to flow from the positive power rail into the positive probe of the DMM, and out of the negative probe of the DMM before going into the resistor. We'll do this by breaking up the circuit here and moving the cable to an unused node. When you do this, leave a bit of the metal tip exposed. Given the power rail potential and the resistor value, I expect the current to be in the milliamp region, so I'll turn the knob to the milliamp range. It's again measuring AC by default, so press the function button to switch to DC. Now, if I touch the power rail with the positive probe and the resistor with the negative probe, the circuit is completed with the current flowing through the DMM, and I get a reading of about 4.7 milliamps. I can do the same thing with the 220 ohm resistor, and here I measure about 20 milliamps. In this case, you need the value of the resistor and the value of VCC, so I knew the current will be fairly small. But if you're expecting a large current, larger than about 600 milliamps in the case of this DMM, you'll need to measure in the 10 amp range. To do this, move the positive probe to the 10 amp jack and set the range to 10 amps. Press the function key to measure DC, and the rest of the steps are the same as before. We see that we're measuring 0.019, 0.020 amps, which is the same as what we measured before. When you're done, remember to return the positive probe back to the other jack, or take both probes out entirely. You can easily blow a fuse if you forget that the probe is in the 10 amp jack next time you're using the DMM, and start taking other measurements. Let's take a look at how we can measure some basic component characteristics like resistance and capacitance. To measure resistance, set the dial to the resistance option and touch the two terminals with the probes. When you're doing this, make sure the resistor is isolated and not connected to anything else. The DMM measures resistance by applying a small voltage and measuring the current. If you have anything else connected, you won't be measuring just the resistor, you'll be measuring the resistance of the resistor plus whatever else you have connected to it. This whatever else includes your hands as well. If I touch both probes with my fingers, you can see that the resistance of my body is about 200 kiloohms. If you hold both ends of the resistor at your hand while you take the measurements, you're effectively putting your body in parallel with the resistor, throwing off the measurements. If I hold a 10 kiloohm resistor in my hands, you can see we measure about 9.3 kiloohms, which is quite a bit lower than the 9.8 kiloohms we measured before. Measuring capacitance is nearly identical to measuring resistance. Again, set the dial to the capacitance option, and measure an isolated capacitor. As you know, diodes and LEDs are components that allow current to flow in one direction, but not in the other. You can use a DMM to quickly check this direction of currents. Turn the dial to the resistance option and press the function key once to switch to diode mode. Touch the two terminals of the LED with the probes. If there is current flowing through it, the DMM will display the forward voltage drop across the diode. There will be no change in display if you get the polarity wrong and there is no current flow. If there is current flow, then current is flowing into the terminal connected to the positive probe, so it's the anode, and the other terminal is the cathode. The last function we'll go over is the continuity test, which should be one of the first things to try when debugging a circuit. It's a very quick and easy test that will let you know whether there are any open circuits, so it's very handy when you want to check that your components are correctly mounted or that there are no breaks in the trace of your PCB. To use this feature, I can press the function key with the dial at the resistance option. First, touch the two probes together to make sure the buzzer is working properly. Then, touch the two resistors with the probes. These two resistors aren't connected at the moment, so you don't hear the buzzer. If I try this again after connecting them, you hear the buzzer, which tells you that there is a good connection. In this tutorial, we looked at how we can use the U9233E digital multimeter to measure electrical characteristics like voltage, currents, resistance and capacitance, as well as to test diode orientation and check for continuity.